So, you guys know the what the three different types of rocks are, correct? Let's hear one of them. Sedimentary, igneous, metamorphic. Very good. Now, when I draw the rock cycle, I'm going to start with one of them, and I'm going to choose one on purpose. The one I start with, I choose on purpose. Which one do you think I'm going to start with? Raise your hand if you think I'm going to start with sedimentary. Raise your hand if you think I'm going to start with metamorphic. Raise your hand if I'm going to start with igneous. Yeah. Why am I going to start with igneous, Emily? First in glossary. Yeah. That's a cheap way to figure it out. Jasmine?
Because it's the most important.
It's not more important, no. Andre? The first rock where? What? The first rocks on Mars?
No.
What planet are we on? Earth. Igneous rocks are the first rocks formed on Earth. Okay, so I'm going to start with igneous rocks.
Can we live on Mars?
No.
Alright, so again, since I just mentioned again, igneous rocks are the first rocks formed on Earth. Let me explain how that's so. Now remember what I said yesterday. Christian, you remember what I said yesterday about it? You want to repeat it for the class? Go for it. That's true, but volcanoes didn't exist until there were igneous rocks.
Oh, I know. Lava cool.
No.
Emily, you want to explain it? Okay, that's correct, but it's important to know that Earth originally was just magma. There was no land. There were no rocks yet. It was originally just a big old ball of liquid magma. And then it cooled enough that the outside layers of the magma were cool enough to solidify it, otherwise known as crystallizing, into rock. And that's what we call igneous rocks, because magma cooling into rock form is igneous rock. So we're going to start with igneous rock, and I'm going to put it at the bottom of my rock cycle diagram here, because magma cooling is underground. When magma cools, it's underground. So that would be the bottom. So I'm going to put it in here just for that reason. It doesn't matter where you put it, but I'm putting it here just because of that. Alright? So there's the igneous rocks. And then we have, what are the other two again?
Sedimentary and metamorphic.
Sedimentary and metamorphic. Alright, sedimentary right here. I need to move this one over a little bit. It's off center. Alright, so we have our igneous rock, metamorphic rock, and sedimentary rock. I'm going to start with igneous rocks. Why am I starting with igneous rocks again? Everybody. Okay. So the igneous rocks, which are rocks formed from magma or lava cooling and crystallizing or solidifying. Okay. If they are weathered, okay, if they get weathered into sediments, sediments are the little fragments of the rock after they've been weathered off of a bigger rock. Okay, if those sediments are carried away and deposited on top of other sediments, and they cement together, it forms a sedimentary rock. Okay? And if the sedimentary rock is changed into a new rock over time because it's put under heat, pressure, and/or chemical reactions, then it becomes a metamorphic rock. And one thing to help you to remember this is metamorphic. Okay? Morph means to change. and something morphed, it changed. Anyone here know the Mighty Morphing Power Rangers?
No.
Morphing, they change, right? They go from being people to like dinosaurs or something, right? Or there's a book series. There's a book series called Animorphs, where an animal or person changes from one animal to a different type of animal, right? Whatever, doesn't matter. The point is, morph means to change, so metamorphic. Okay. Moving on. Yeah. It metamorphoses. Okay? Alright. So, if this metamorphic rock then gets heated enough and it melts and becomes magma, and then that magma cools and crystallizes or solidifies, and you're going to hear me say both solidifies and crystallizes, and you're going to have to know that I mean either one. It means the same thing as far as this goes, okay? So, if the metamorphic rock melts into magma, the magma cools and solidifies, or crystallizes, it then becomes a what? An igneous rock. Alright? But wait, there's more. There's more. No. We're not done yet. If this igneous rock changes over time, due to heat, pressure, and or chemical reactions, then it becomes a metamorphic rock. An example of that I showed you yesterday with the granite. The granite, when it put under heat and pressure over a long period of time, it becomes nice. Yes. Alright? Alright, if the metamorphic rock is weathered into sediments, and the sediments are deposited on other sediments, and they cement together, it forms a sedimentary rock. If the sedimentary rock is heated enough to melt and it becomes magma, then that magma cools and solidifies again. It then becomes an igneous rock. But wait, there's more. There's more. We're not done yet. Check it out. If this igneous rock melts and becomes magma again, and then that magma cools and solidifies or crystallizes, then it becomes a new igneous rock. There's more. Wait, there's more. There's more. If this metamorphic rock gets heated and it gets put under more pressure, or there's another chemical reaction, it'll change again into a new metamorphic rock. Oh wait, there's more! There's more! Oh my God! If the sedimentary rock is weathered into sediments, and those sediments are deposited with other sediments, and they bond together, they cement together, it forms a new sedimentary rock.
I like it.
And now we are complete. We have our Rock Cycle cow.
Okay, that's a big sound. Oh my God.
You guys see the cow? You see the cow?